Abel's theorem, first form: if the power series sigma n varies from 0 to infinity an x raised to power n converges at the end point x equals to r of the interval of the convergence open interval minus r to r, show that it is uniformly convergent in closed interval 0 to r. Proof: let S and P equals to Cn plus 1 r raised to power n plus 1 plus so on plus Cnp r raised to power n plus p equals to 1, 2 and so on. Then clearly Cn plus 1 r n plus 1 equals to S n1 Cn plus 2 r raised to power n plus 2 equals to S n2 minus S n1 so on. C n plus p r raised to power n plus p equals to S n p minus S n p minus 1. Let epsilon greater than 0 be given, since the series sigma n0 to infinity Cn r raised to power n is convergent. Therefore, by the Cauchy's general principle of the convergence, there exists as m belongs to n such that modulus S and P is less than epsilon for all values of n is greater than equals to m and p is greater than 1. Equation 1. Also x upon r n raised to power n plus p is less than x upon r raised to power n plus p minus 1 is less than equal to so on less than equal to x upon r raised to power n plus 1 less than equal to 1 for 0 is less than equal to x is less than equal to capital R. Therefore, we have modulus Cn plus 1 x raised to power n plus 1 plus Cn2 x raised to power n plus 2 plus so on plus Cn plus p x raised to power n plus p equals to modulus Cn plus 1 r raised to power n plus 1 into x raised upon r raised to power n plus 1 plus Cn2 r raised to power n plus 2 x upon r raised to power n plus 2 so on plus Cn plus p r raised to power n plus p into x upon r raised to power n plus p equals to modulus Sn1 x upon r raised to power n plus 1 Sn2 minus Sn1 into x upon r raised to power n plus 2 so on plus Snp minus Snp minus 1 x upon r raised to power n plus p equals to modulus Sn1 into x upon r raised to power n plus 1 minus x upon r raised to power n plus 2 so on plus Snp minus 1 x upon r raised to power n plus p minus 1 x upon r raised to power n plus p plus S n p into x upon r raised to power n plus p equals to Sn1 x upon r raised to power n plus 1 minus x upon r raised to power n plus 2 so on plus Sn p minus 1 x upon r raised to power n plus p minus 1 minus x upon r raised to power n plus p plus modulus Snp into x upon r raised to power n plus p. Equation 2, since x upon r raised to power n is a monotonically non-increasing for all x belongs to close interval 0 to r using 1, and therefore 2 becomes modulus Cn plus 1 x raised to power n plus 1 plus so on plus Cn plus p x raised to power n plus p is less than equal to of epsilon x upon r raised to power n plus 1 minus x upon r raised to power n plus 2 plus so on plus epsilon into x upon r n plus p minus 1 minus x upon r raised to power n plus p plus epsilon into x upon r raised to power n plus p is less than epsilon upon x upon r raised to n plus 1 is less than epsilon for all values of n is greater than equal to m and p is greater than 1 and x belongs to close interval 0 to r. Hence the Cauchy's principle for the uniformly convergence, the power series sigma n varies from 0 to infinity Cnx and converges uniformly on close interval 0 to r.